In section 3 of chapter 2, we're going to be graphing quadratic functions with individual transformations. Again, I'm going to act like this is a brand new function you guys have never graphed before, so I'm going to do the same thing I always do, which is utilize a t-table. If you do not know how to graph something, t-tables are your bread and butter. It's your go-to. It's the basic fundamental upon everything in graphing is built off of. You're going to pick inputs for x, and you're going to find the outputs for y. That means you're going to find numbers to plug into x. You get to pick anything you want. I'm going to pick the numbers -1, -2, -3, 0. Why did I put it that way? Sorry about that. I'm going to do -3, -2, -1, 0, 1, 2, and 3. There we go. So I'm going to take those numbers, which I kind of picked at random, but I picked them in sequential order, and I'm going to substitute them into the equation for x and find out what the heck the output is. So for the -3, I'm going to get the quantity -3 quantity squared. Squaring is just multiplying a number times itself, so that's just -3 times -3, which is equal to +9. So that's my output. Left 3, up 9, which is right here. Then I'm going to do -2. -2 squared is equal to -2 times -2, which is +4. Therefore, my coordinate is left 2, up 4. Left 2, up 1, 2, 3, 4. There's the dot for that. And then I'm going to utilize -1 as my input. That's going to give me -1 quantity squared. That's -1 times -1, which is +1. So we're going to go left 1, up 1. And then we're going to utilize 0 to get the quantity 0. Quantity squared, 0 times 0 is 0. So surprise, surprise, this mother function goes to the origin. Then we do the same exact thing for the positive iterations of those numbers. So I'm going to plug in 1. 1 times 1 is 1. So we're going to go right 1, up 1. Then we're going to plug in 2. 2 squared is 2 times 2, which is 4. So we're going to go right 2, up 4. And then last but certainly not least, we're going to utilize the 3. 3 squared is equal to 3 times 3, which is 9. So right 3, up 9. I know I powered through this really quickly, but this is the shape of a parabola. You should all be familiar at least somewhat with these. We are going to spend a large portion of our time in Algebra 2 going over parabolas and their utilizations. Parabolas are an amazing function. They model a lot of really interesting things mathematically.